Okay, welcome, ladies and gentlemen, to our webinar, the Reflect webinar on the European Fluid Atlas. My name is Katrin Kieling. I'm working at the Helmholtz Zentrum Potsdam, GFZ, the German Research Center for Geosciences, and I'm the project manager of the Reflect project, which is an Horizon 2020 project on redefining geothermal fluid properties at extreme conditions to optimize future geothermal energy extraction. In this project, I have the pleasure to work along with a number of outstanding researchers from approximately 10 different European countries who are committed to close gaps in database and in the basic understanding of chemical and physical fluid properties of geothermal fluids. And with that, we would like to avoid in the future unwanted processes during the geothermal operation. Today, we would like to focus on the European Geothermal Fluid Atlas, which is a database of geothermal fluids in Europe and brings together pre-existing data on geothermal fluids with new sample analysis in the Reflect project. I have the pleasure to welcome today 3 of our Reflect project partners to this webinar. We will start with a presentation of the coordinator of the Reflect project, Simona Regenspurg from GFZ Potsdam. Then this will be followed by a presentation by Eva Hartai from the University of Miskolc on the data collection for the Fluid Atlas. And finally, Károly Kovács from the University of Miskolc will provide you with some more details on the current state of the Fluid Atlas and will also give a preview of the Atlas. Each of the presentations will be followed by 5 to 10 minutes question and answer session. And for that, please type your questions into the chat and I will read them out loud to the presenters. And I encourage you to type your questions already during the presentations such that we then later can start immediately with the questions in the session. As a last remark, I would like to remind you that the webinar will be recorded and my colleagues Alberto Sanchez and Maria Lopez from the European Federation of Geologists, who have actually organized this webinar, they will publish the recorded webinar then later on YouTube. Having said that, I think we're now ready with the introduction and we will now start with the first presentation by Simona Regensburg. Simona Regenspurg is working as a research associate at the Helmholtz Zentrum Potsdam German Research Center for Geosciences in the section Geoenergy since 2009. Simona studied geology and hydrogeology at the Ludwig Maximilians University in Munich in Germany and completed then research stays in the US, in Sweden, and in Switzerland. She habilitated and teaches also at the Free University of Berlin. Currently, she is head of the working group Geothermal Fluids in the Geoenergy section of GFZ, and her focus of her research is on the study of geochemical processes that take place during the operation of geothermal plants. This includes reactions under increased pressure and temperature conditions and interactions between water and rock and the effects on the environment. She is the coordinator of the Reflect project, and with that, she's also the scientific head of the project. And with that, I would like to hand over to Simona. The floor is yours.
Thank you, Katrin, for the nice introduction. So welcome, everybody, to our webinar series. I'm very happy to give you some background information about the Reflect project and also our short introduction to the Geothermal Fluid Atlas that's developed within the project. So as Katrin said, it stands for the abbreviation stands for redefining geothermal fluid properties at extreme conditions to optimize future energy extraction, and it answered an EU call on optimizing manufacturing and system operation. It is a 3-year project started in 2020. So that means we are already approaching slowly the end. It's coordinated by us at GFZ, and we are about 14 partners from different institutes distributed all across Europe. The background of the Reflect project is that many geothermal operators have problems that are related to scaling That means mineral precipitation and corrosion. You see here a couple of examples on these pictures of scaling and corrosion. So these problems, they cause downtime, maintenance costs, and even failure of geothermal installations. And the reason why it happens why scaling and corrosion happens is because it comes to reactions of the fluid with the materials, and they are very difficult to predict. And this is because the properties of the fluid are actually not very well known. And the properties of the fluids, they can be roughly explained by two main parameters, that is salinity and temperature. And the diagram here shows you why we talk about extreme conditions for geothermal fluids. So you see temperature and salinity of the geothermal fluids, and most fluids are either of very high temperatures, so it goes up to several hundred, even over 400 degrees C. These fluids are usually of lower salinity, or you have the very high salinity of up to 400 grams per liter salt content, and lower temperature, like in sedimentary basins. And these fluids, both extremes, are very difficult, like that you can predict any geochemical reactions, because you see here in the dashed area, these are the areas where fluid properties are not well characterized, like gas dissolution, mineral solubility, fluid physics, silica precipitation kinetics, or the occurrence of microorganisms or organics in the geothermal fluids. So these are all not very well understood and addressed now in the REFLECT project. Yeah, the REFLECT project, I should also mention, focuses on temperatures above 100 degrees C, so really the high temperature geothermal fluids. The objective of REFLECT is therefore to do accurate predictions by thorough knowledge of the physical and chemical properties of the fluids, and our concept or slogan is from react to reflect. That means to avoid the problems that are related to fluid chemistry rather than just to treat them. And with that, we follow 7 goals, and these goals are also mirrored in the structure of the project. You see the structure here on the right. There are mainly 2 work packages. One focuses on the hot fluid, like the very high entropy geothermal fluids, and the other on the highly saline fluids. And in these fluids, we try to generate data that are not well known, and these are listed here. These are the goals: to extend databases for mineral precipitations to higher temperatures and salinities by lab experiments and modeling approaches, to determine extent and location of the degasification front of the fluids, to determine types of organic matter and microorganisms, and to determine fluid physical parameters, and also to develop a downhole sampling technique for hot and super hot systems. And when we generated data, then in the other 2 work packages, we try to apply them, these new data. This means applying them then in reactive transport modeling, this work package 4, and to set up a geothermal fluid atlas with as many of these data as possible. And this is what the webinar today is about. So the approach for the Digital Fluid Atlas for Europe is to collect information on the properties of the fluids throughout Europe. These include geographical, geological, physical, chemical, and microbial properties. And the purpose is to give information needed for planning and managing geothermal facilities, and thus to facilitate future geothermal projects. That means we try within the project to collect existing data, but also to measure as much data as possible from certain sites that are integrated in the REFLECT project. Here you see the sites all across Europe where we look at. These are high salinity sites, high temperature sites, or some sites that are actually both. And in these sites, or for these sites, we look at or collect data, all data that are basically possible: physical chemical parameters, all cations, anions, isotopes, gases, information about the scales, about organics and microorganisms, and even about radionuclides. So that we get, at least for these sites, a really good data set. But in general, data are really difficult to collect, And we, besides what we will hear later of Károly and Eva about the Fluid Atlas, we had 4 associated projects that were led by students, master and bachelor students, who collected these data for certain regions. So we had a student who looked more in Iceland, one in Germany, and one in Netherlands and Turkey. And with all these student projects, there were different questions also behind, different tasks that could be answered by the data that were collected. And for all these projects, we worked with different institutes that supported us, like the VGR in Germany, the Freie University, Bundesamt für Strahlenschutz, or ESO in Iceland, and the Technical University of Delft. So with that, we got some projects that shows what the Fluid Atlas actually can do, and also shows how the data were collected. So I'll give you a brief overview about what these student projects, what they actually did. So Nina Pogarel, for example, she looked at the properties of geothermal fluids in Germany with a special focus on lithium and strontium. She collected like data from altogether 90 wells, looked at 100 fluid data and some other reservoir and rock sample data. You see the regions in Germany are, there's 3 geothermal regions in Germany. And when it came to lithium and strontium, that are both critical raw materials, here the data were getting more scarce. So there were just 11 wells in the North German basin, 5 wells in the Upper Rhine Valley, and 7 wells in the Molasse basin that gave these values. And with that, she found actually that, yeah, that there's very high concentrations of strontium and lithium in the North German basin. In the Upper Rhine Valley, it was also quite high, not that high, whereas in the Molasse basin, hardly any lithium and strontium were found. So the atlas can give here information, if one knows about lithium and strontium in this fluid, can give information on the benefit of geothermal fluid with respect to the content of potential critical raw materials. The next student work from Daniela Wenzel was about fluids in Iceland. So she also collected all data of geothermal fluids that were available in Iceland, and with a special focus on silica, boron, and fluoride. You see the map of Iceland with the main geothermal region. She looked at and she collected a lot of data, so there were really many data available that can be used for determining fluid origin and maturity, like you see here in the Gegenbach diagrams. I will not go into detail about what they tell you. That mainly gives you information about the origin of the fluids. But she also did, as I said, look at silica, boron, and fluoride. And next other example is here from the Krafla area, different wells, and how silica concentration is distributed in these wells. And you see some areas contain very high silica. That gives you information about the temperature of the reservoir and also about scaling potential of silica. So this information that she collected were about, yes, getting information on origin of fluids, of scaling potential, and also about the toxicity of geothermal fluids, because boron and fluoride are both toxic elements. The third thesis, she did not look at one special region, but at all the geothermal sites that are included in the REFLECT project, collected the data and looked here for radionuclides. Many fluids contain radionuclides that pose a risk for the operators. The waste that contains a lot of radionuclides have to go to special waste depositories. And she measured these radionuclides and fluids from the different sites. And you see here what she found. So the so-called norm or natural occurring radionuclides in fluids were measured, and you see some of the sites, especially the crystalline and the sandstone site, they contain a lot of uranium, a lot of radium, and 226, 228, and radium and lead 220. she also tried to investigate the interactions between the geothermal fluids and like salt content or temperature to see if there are any correlations. And show here just some correlation plots. So there's a slight correlation with both with salinity and with chloride content for here for radium 226 and for lead 210. So the atlas can here in this case give you information on risk of geothermal fluids, which is important if for the waste disposal in the end for the operators. And the last example, that is the thesis, the master thesis of Jean Stein. She looked at environmental risk related to geothermal fluids and did an integrated approach from natural and social sides. So she looked at 3 regions, 2 reflect regions, Turkey and the Netherlands, and also to Indonesia, where we have all very different geologies, and looked not only at the fluid chemistry data, but also at social data in terms of risk perception of the population. So she took the geothermal fluid data and measured specifically or looked specifically at the toxic elements like aluminum, arsenic, cadmium, fluorine, mercury, and lead for the 3 regions, and could determine by comparison this data from World Health Organization and also relative to the other countries if there are high or low or moderate risks. And then on the other hand, in terms of risk classification, she did develop questionnaires that went to the population in these areas and ask the people basically if there is any concerns about either groundwater contaminations or air pollutions, and she got some different answers in the different countries if the people are concerned or not. So in this case, it's more like a future application, because the data that can be used from the Fluid Atlas, they can be used to improve social acceptance, possibly. So with that, as to summarize how the Fluid Atlas can actually be applied, it can be applied to get information about the content of critical raw materials in fluids, gives information about fluid origin, about scaling and corrosion potential, about the toxicity of geothermal fluids, specifically also in terms of waste disposal and naturally occurring radionuclides. And yeah, it can also be used, or the data can be used to improve possibly the social acceptance of geothermal energy. And with that, I want to thank you for your attention, specifically also to the 4 students and their other supervisors. Thanks. And I'm happy about questions.
Thanks a lot, Simona, for the nice presentation. I invite you again to pose questions in the question and answer tool. And until we have the first questions from the audience, which is not yet the case, maybe I can pose a question. Simona, you showed that for Germany and the critical raw materials, the distribution is relatively smooth over a certain region, I would say. So you have these different regions, and the results are relatively consistent, while for the silica content in Iceland was very, very different already for one reservoir in Katla. Is this due to the element which was considered, or is this due to the fact that volcanic regions are always much more variable than these basin structures which we have in Germany?
Yeah, it depends both on the geology and on the temperature. For silica, mainly the temperature determines how much is dissolved. So in the very deep wells in the Krafla area, they have very high silica content, and that is not so much dependent on the geology, but more on the depths of the fluid. Whereas in Germany, the different, especially the sedimentary formation, they contain different elements depending on the age and the type of the formation, like the minerals that are included there, the age of the fluid. It's a bit more complex, I'd say.
Mm-hmm. Okay, thanks. Then there's a more practical question. Is it possible that we can get and read Janne Stein's report, please? I think that's possible, maybe you can contact us directly via the contact on our, which is provided on our webpage, www.reflect-h2020.eu, and there you can find our contact, and we can then send you the report. Other questions? Not at the moment. Maybe coming back to to Janus Stein's thesis, you said that she evaluated also the concerns of people concerning different air pollution or groundwater pollution. So do you have any information on who the people were? So did they already have some knowledge about geothermal, or was this out of the blue? Or was there already some information provided on geothermal before she sent the questionnaire?
Yeah, that is a very crucial question, actually, before evaluating these questionnaires, because you have to know whom you're asking, of course. And in that case, it was, as far as I'm correctly informed, it was mainly people from the geothermal sector, so people who knew what geothermal is and how it works, and people working actually in the geothermal application directly.
Okay.
Yes.
Thanks. There's a question from Walter Tavecchio. Is there any technology to clean the rust in the pipes during the extraction of hot and mineralized fluids?
During the reaction, I think usually during the production, I think it's difficult for really, I mean, if you do mechanical cleaning, probably not. If one injects chemical like HCl or so to dissolve anything, well, it's more for dissolving scaling, not for rust. I'm not so experienced as an operator, but I would guess it's not so easy to have it at the same time. You probably have to stop the pumps and do the work over, and then so this is a downtime that you have when cleaning these things. That is a problem. Why avoiding the things?
Yeah, I think that answers the purpose of the Reflect project already. So we really want that we can avoid this beforehand and develop methods to either operate.
Oh, Katrin, you've been frozen, but it's okay. You're back.
Okay, great. Yeah. So this is really the aim of the Reflect project, to avoid such things before you have to do the work over. So we have more questions. Have you some medium data of groundwater contamination? I'm not sure whether I understand the question.
I assume it's about the content of like toxic components in the different fluid, and that is exactly what the Fluid Atlas is about, to get as many data as possible on contaminants, also not only ingredients but also on contaminants, and that depends on the region. Sometimes there's good information, but for most elements, I think the information is still scarce. So, but it's something to be implemented in the Atlas in the end.
Okay, thank you. There's another question whether we can provide a copy of the presentations. Yes, I think they will be provided to the participants of the webinar afterwards. And then there's another question about lithium in the waters. The person missed the presentation. I think you can maybe very quickly repeat about lithium.
Yeah, lithium is of course of high interest currently for many geothermal operators, because it occurs often in geothermal fluids. We had that study of Nina Pogarel, who for Germany, who did an overview about the data on lithium, also on strontium, in her case, in the geothermal waters. There were not for all geothermal wells information available, but what she found was that specifically in the North German basin, there were very high lithium concentrations in the fluids, and but also high concentration in the Upper Rhine Valley. In the Upper Rhine Valley, there's a lot of activities actually going on currently in terms of lithium extraction. So there are the companies who are now, yes, trying to extract it for economic purpose.
There's another question in the chat. Sampling is critical in determining composition. Can we talk about surface sampling or depth sampling in the examples mentioned? So
yes, well, usually samples are collected at the surface because it's much easier if the fluid is pumped up. But sometimes one gets, of course, also it's possible to collect deep fluid samples. It's more it takes more effort to do so because you need special fluid samplers that collect at the temperature and pressures. But it's possible. It gives information, of course, about gas content, and also you will not have any or not too many chemical reactions during the ascent of the fluid. That usually happens. But yeah, still most fluids are sampled at the surface, and most of the data also in the Fluid Atlas will be surface analyzed samples. But this is an important question and always has to be considered. For some elements it is difficult. Like I know from the work of Daniela, who did the silica analysis, she recalculated the silica content always back to reservoir conditions, because what you measure at the surface is not the same like in the reservoir.
okay, thanks. And maybe I add also that in the Fluid Atlas, it will be indicated whether it's a surface sampling or depth sampling. So this is one of the data points which we collect if we have fluid samples in the Fluid Atlas. I think at this point I would like to move on to the second presentation. Thanks a lot, Simona, for the presentation and the answers. And now we would like to continue with Eva Hartai. I have the pleasure to introduce her. She's a geologist and honorary professor at the University of Miskolc in Hungary. Her research area is ore geology and mineral resources. Eva has 45 years of teaching experience leading courses in physical geology, environmental geology, and mineral deposits. She was also editor-in-chief of the European Geologist Journal for 9 years and the coordinator of the EFG panel of experts on education. Eva has taken part in numerous EU-funded and national projects as a coordinator, also as a work package leader. For example, in the CHPM 2030 projects on which Reflect kind of also builds a bit, and we are happy that she brings her experience to the Reflect project. And now she will present you the data collection which was performed for the Reflect Fluid Atlas. Eva.
Thank you very much for this kind introduction, Katrin. As it was explained and you could hear, our University of Miskolc was responsible for the creation of the European Fluid Atlas and also for the related data collection. When we started to think about this work at all, the basic concept was to create a comprehensive digital fluid atlas with a wide geographical coverage, which can be used for scientific purposes by the research community, but can be also useful for operators and investors if they want to establish a new geothermal facility. So we collected data from all over Europe, and first of all, about fluids, the high temperature fluids, which are used for generation of electricity. But in order to be complete, we also considered lower temperature fluids from heating facilities. The focus was on the fluid data, but we also collected the related well, rock, and reservoir data. What were the data sources? We had the so-called old data and new data. What do we mean by old data? Old data are those data which are pre-existing, which existed before the project started. And the new data were generated within the project by the project partners. Where do old data come from? First, they were collected by the so-called EFG LTPs. What does that mean? EFG is the European Federation of Geologists. It's a Europe-wide professional organization which involves the national member geological associations in 28 countries in Europe. Not all of them participated, but 10 of them, and so 20 of them and 20 countries. It means that 20 European countries are covered by data collection at national level by these national associations, who they are called so-called linked third parties. And then not only these LTPs, but also the partners, main project partners collected data from the sampling sites. Later I will introduce these sampling sites, and also from other geothermal sites in their country. And new data, of course, which were generated within the project lifetime, these new data were collected by the partners from the sampling sites. The first step was to create a data collection template. The template is an Excel file. This Excel file contains 4 working sheets. The first sheet is dedicated to the well data. The wells are listed vertically on the sheet, and here in the columns you can see the different kinds of data. So actually we asked for 22 kinds of data about the wells. These are geographical data, the data on the physical properties, and so on. The second sheet is about the fluids, the fluid samples, referring to the wells, of course. Fluid samples, again, listed vertically, and this is quite a detailed sheet because we ask for 82 kinds of data on the fluid samples. These are related to the sampling process and also the physical and chemical properties, and especially the chemical properties are quite detailed because we listed all potential cations, anions, dissolved gas, and so on. It doesn't mean, of course, that someone who fills the template has to fill every single cell, but we didn't want to lose any kind of data. That's why it is so detailed. The third sheet is about the rock sample data. Here we have 18 kinds of data, 18 columns, about the geology, the physical properties of the rock samples. And finally, the reservoir data. This is also a separate sheet with 26 columns. First, a few words about the data collection by these national member geological associations, the so-called ATPs. As I mentioned before, they covered 20 countries. These 20 countries are listed here. And what was the source for collecting the data? These LTPs collected data on national level, national language publications, and public databases, authority studies, technical reports. You see that we have quite a good geographical coverage in Europe. During this process, we faced a few problems. First of all, that the data density varies greatly by country. And there were also problems with the data format, but we can manage this during the process of the data assessment. So as an outcome from this process, we have the data, almost 3,000 wells, near 2,000 fluid samples, 200 rock samples, and almost 200 reservoirs. This process and the outcomes are summarized in a report on the data collection by the LTPs, which is also deliverable and available on the project website. Here the problem is illustrated, I mentioned before. The diversity in data density. For example, you see that from Italy, we have the data of almost 1,000 wells. I would like to emphasize again that these graphs do not show the number of data, they show the number of wells, fluid samples, rock samples, and reservoirs from which we have the data. So back to the point, this is the Italy, from where we have almost 1,000 data of almost 1,000 wells, but do not have fluid data at all or rock data. We have some reservoir data, and the same was the problem with the UK LTP, who could provide only well data. So the problem is that the data accessibility and the related restrictions and regulations are quite different in the different countries. So this is the reason why we have this problem. But in this case, in the UK case, the problem was later solved because the UK main partner, British Geological Survey, added fluid data and rock data to this well data. So until now, I have spoken about the data collection by the national associations. Now, let's see the data collection by the project partners. Simona mentioned that we have 14 project partners, but this 14, it is 8 which were involved in this data collection process. University of Miskolc coordinated the data collection, and the GFZ, BRGM, Hydroisotope from Germany, TNO from the Netherlands, Iceland Geosurvey, Izmir Technology Institute, and BGS from the UK provided data. What kind of data? Also, as I mentioned before, the old data for the sampling sites, old data for also other locations in the given country, and new data for the sampling sites. 11 sampling sites were identified when we started the data collection, but later Balmat from the Vito side from Belgium was also added. So this process is also summarized, and the outcomes are summarized in a report, also deliverable, and this report is also available on the project website. Here the sampling sites are listed, 11 sampling sites from 7 countries. So Bad Plumau, Poyant from the Caribbean, France, 3 sites from Germany, 2 sites from Iceland, 1 from the Netherlands, 2 from Turkey, and United Dons from the UK. The geological background is quite diverse. We have carbonate rocks, also siliciclastic rocks, volcanics, metamorphic rocks, and granite. The sampling sites are visualized here. 10 sampling sites are here in mainland Europe, and 1 from buoyant from the Caribbean, France, and also the operators are indicated. This graph shows the number of wells, fluid samples, rock samples, and reservoirs from which we have old data by the partners. So definitely for the sampling sites. So although we had 11 sampling sites, these old data could be provided only for 6 sites. From Krafla, we have a really large amount of the data of a really large amount of fluid samples, and also from buoyant, we have a large number of fluid samples. But we also have all data for Groß-Schönebeck, Isheim, or Neustadt-Gliebe, and also Testereit here in Iceland. This graph shows again the number of wells and fluid samples from which we have data. We have new data generated within the project lifetime. And from the sites in Turkey, we also have rock sample. Also have data of rock samples. Unfortunately, we have a problem here with the United Dons in the UK, because there are restrictions by the operators, and these fluid data are not accessible for the moment, but we hope that they will be public within the project lifetime later, and we can add the fluid data from United Dons to the Fluid Atlas. Here, the other geothermal locations are shown. So all the data by partners, not the RTPs, but partners for other geothermal locations. We have these all data for Germany, Turkey, UK, and the French Rhine-Graben and Lomantin in Caribbean, France. From Turkey, the largest amount of fluid samples and rock samples, wells and fluid samples. So as a summary, let's see first how we stand with the sampling sites. For the sampling sites, we have data only by the project partners, the main partners. They provided old data, formerly existing data for the sampling sites, and also new data for the sampling sites. So altogether, we can say that for these 11 sampling sites, we have the data of about 120 wells, about 1,300 fluid samples, about 100 rock samples, and the data of 4 reservoirs. This is for the sampling sites. And if we consider the other locations, data were provided by the linked third parties and by 4 project partners, linked third parties for these 20 countries. And among these 20 countries, those are also listed from where additional data were collected by these project partners. So altogether, we have about 3,000 wells, about 2,200 fluid samples, about 300 rock samples, and about 200 reservoirs. So as I was responsible for the organization of this data collection, so my presentation was quite I can say that administrative approach. So I provided a lot of data, and I wouldn't tell you any details about the nature of the data. But I think that these numbers are impressive, and we are still in the data collection process because new data for the sampling sites are still generated. And we are in the stage of the data processing now. I mentioned these problems with the uneven data distribution and the problems with the data format, but we can manage these problems. A thorough data quality is needed, and we are just working on that, how to execute, how to carry out this data quality check. So that was all from my side, and thank you for your attention.
Thank you very much, Eva, for the presentation of the data collection. We already have one first question in the Q&A, and I invite all the others also to post questions. The first is, there's no information referring to the type of well and the shape. By this, I mean, are these wells vertical or directional? If they are directional, then what is the shape of the well? And is it possible to have them included?
Unfortunately, we have no data on that. So maybe if needed, we can complete the template and we can look for this kind of data. But we, for the first approach, we counted only with vertical wells.
Yes, I think we have the location of the wells and the depth, but not the shape of the well. There's another question. I see Spain in the list of countries, but I do not see Spanish data in your graphs. Could you say something about the origin of Spanish data?
The Spanish data, in Spain it was the National Member Association of EFG, which collected data. So as we have no project partner from Spain, the data were provided by this National Member Association. Was it a question?
Yes, I think so. And then there's a question in the chat. Do you plan to put all these data on a GIS and make them available? I think Károly will answer this in his presentation. So I think we can skip this for the moment and ask for your patience. It will be answered in the next presentation. Eva, do you think that the restriction of the data access is the biggest problem in this data collection, or so?
So yes, it's a big problem, but we cannot help about that. If there is a regulation in a given country, we cannot interfere. We cannot solve this problem. The only way is if we try to push the given linked third party to collect data from the available literature, because I can accept that they cannot collect data from reports, because these reports or technical reports are not accessible publicly, but most of the publications are open access and available. So we are in contact with these partners and ask them to move on a little.
Okay, thank you. There's another question. Do the rock samples, are the rock samples all coming from wells? So does it mean from various depths? Do you have information on this?
As far as I know, all the rock samples are from wells, from the drill holes. Yeah.
Okay, I think that's it in terms of questions for the moment. Thank you very much, Eva, for the nice presentation. And we will now move on to the to Károly Kovács, who will also present on the Fluid Atlas a bit more about more details and also provide a preview. Károly is a geographer and a research assistant at the University of Miskolc. His main research area is digital soil mapping, but he's also interested in other environmental modeling projects as runoff, erosion, or flash flood modeling. Connected to this is field data collection, remote sensing, and just GIS data processing and database development. As part of the REFLECT project, he is developing the database behind the Fluid Atlas, and he's also creating the web-based visualization of the Atlas. And with that, I would like to hand over to you, Károly.
Thank you. I share my presentation. Welcome, everybody. Thank you for the interest which is shown for the, I hope it's working. So my name is Károly Kovács, thank you. And I just go through the first slides of mine because the previous two presenters already introduced how the data was collected, the aim why we collected. At the aim, I would reflect to the previous presenters that Eva mentioned that we created these templates huge with 82 columns of entries and things like this because we did not want to lose any data that can be available. And it also shows that this European Fluid Atlas doesn't have a real narrow specific idea on collecting the data, but we want to collect as many data as possible. So it's not as narrow that could, so it's not as narrow the aim of collecting the data and this results of this uneven data distribution that Eva mentioned previously. But European Fluid Atlas got, I think, a really nice name, and this will serve as a visualization tool and the base map and the query and download toolkit of the dataset collected during the REFLECT project. Hopefully, it will still be alive after funded periods, and let's see how it's gonna go. We could see data sources. It was already sorted by Eva in the previous presentation. It also shows that the diverse, even the sources of the data is very diverse, which results We had to work a lot to harmonize the entries, even number formats, date formats, or there was work on units, transforms. So it really came together from many places, sources, and yeah, it now looks a bit better. And for summertime, hopefully it will be available in a really nice and clean up format for the public. We could see well data contains the basic information. In the structure of the data set, it's important that well data has the geocoding, the coordinates that this data set will be the GIS set, which can be mapped, and the dots shown on any background we will choose. And to this well data, we relate the fluid samples, the rock samples, and the reservoir data. The reservoir data will serve within the structure as a grouping of the wells, but it will not work for each of the countries were listed in the previous presentations, because yeah, reservoir data is not available for each of the wells. But this will help quite a lot, for example, to understand the in quality check, for example, within a reservoir, we have a better interval of values for certain fluid properties. So it has a purpose. Hopefully we will get more detailed of the reservoir data set. The data quality, it was mentioned, obviously, as it comes from so many sources that the quality itself can also vary from reliable source to let's see, whatever. And as so many people worked on to put together all the data set, even mistyping mistakes can appear within the data set. We will publish the database on GFZ's open access repository, and for this we are obliged to create at least, but we will work more on that obviously, but at least the reference part. Each of the entries has, so there is a reference column, each of the entries has, or not, a reference, but most of it, in quite around 60–70% of the lines has reference entries, which some of them are DOIs, some of them are technical reports, some of them we are still investigating because of some abbreviations from national geological journals or whatever. But the very first base of the quality check will refer to the data source reliability, and we will flag the entries like it has reference, no reference, and if we can, we kind of do it more shady and let's say indicate the reliability of the reference. We will publish data paper altogether with the repository publishing, which will explain detailedly the data itself, the data collection, selection, and the quality check method. And we are still working together with the consortia to create these, well, these geochemical thumb rule based quality check, which means that, well, professionals know that certain values can be within a range or this way. So this is the quality check. It's hopefully will be ready for summer. We promised the data publishing for summertime this year, and step forward. Okay, so European Fluid Atlas itself is once this database which is collected, and then a tool set and the web-based map, which will published at the end of the project. A beta version will be visualized already on this summer, and it will be hosted from University of Miskolc. We will set up the server stations. I just want to show some of the examples what we've been checking through, and maybe for some of you it will be even useful information. Exists the very classic atlas of geothermal resources in Europe. It appeared in printed version too. It's still downloadable in PDF format. This contains those kind of beautiful isoline maps for each countries within Europe, but our dataset does not look like this. There is one interesting dataset which is available through on the internet. This GeoELEC project created three-dimensional thermic rasters models of Europe, and this dataset is available. They tried to create some web-based visualization, but it's not available now. I don't know what happened, but more or less this is also a structure we could we will apply for our dataset, where we can set some symbology, and there are the buttons and possibilities for download and query. We want to use these kind of rasters as background. It helps quite a lot, even more than Google Earth backgrounds or OpenStreetMap backgrounds, because these rasters are available, and we're gonna put it behind our data set, so the visualization will help quite a lot with these models. Perform data also collected approximately 40 wells and more or less 40 fluid samples during its duration. It's available in Excel and Postgre SQL format for download, and it also has a little map appearance. This dataset is included in ours with the authors together, so legally. Okay, RoboMiners, there are also some of these kind of visualizations, which it starts with the thing that these wells are point data, and point data can be only a point on a map, cannot be a nice colorful topographic map or something like this. So what we have to now are working on is how it can be the best for query, and how to best to look through the entire stuff. RoboMiners collected the mine dataset, and it has this kind of visualization that by clicking on the point, we can get with this more button PDF background report to download. CHPM also has quite a lot of data. It's more like OR data sets, but as you can see here, you can change the background, and which is important, that is possible that we create more or less the same structure that with these buttons on the top, we can divide the data set to structurize the visualization and not having all this big amount together for later on. GeoEra is a collection of data sets. We want to join this too. We would like to join to this initiative and have our data set published through GeoEra too. They have quite a nice collection of already created data sets. None of them is geothermal. What I wanted to say that going through the available data sets and checking the net for any available data, until now, this Reflect is we can say the hugest of its kind, with these 2,700 wells and 4,500 fluid sample data, which is obviously not as detailed as the collection template was, but it's still quite an impressive collection. If we go on the present state, yeah, now we still have work for the quality check. We still have work for example, we are working on the reference part to go through and some automation that can collect the kind of references. It's still under construction how we're gonna go through it, but the automations for the very first thing was is to clean up the coordinates. Obviously, they could not get in standardized format from so many sources into the database, and there were also problems with the entry formats, dates and numbers, and these kind of things. And now we work with ArcGIS desktop software. This is available for us right now, and we're gonna create the web server probably with QGIS web server services, but it's still under construction. Here we can see, for example, for Hungary, what we want to create is the symbology. For now, it's only the categories that could be presented here. For example, different reservoirs of the Hungarian geothermal wells, and exist the well, the rock, the reservoir, and fluid tables, and already the relations are created, so we can kind of lithium is high or dense 0.5 query run through here, and it already shows us the wells within the Hungarian country code. I mentioned we would like to use background rosters, not only, for example, put the database on Google Earth images or OpenStreetMap backgrounds, but also use, for example, topographic maps can help for experts at least to know what kind of areas they are on. And we want to use the previously mentioned models of the GeoELEC project. For example, the Reflect database, the European part. I did not put those 2 points from French Caribbean on the presentation, on the basal heat flow model of Europe. Okay, it looks like when we put it on Google Earth, it's quite useful anyway, because all the wells we can randomly check if they are, for example, on the map really existing. We did some of these, and these backgrounds can be also useful and easy to create, but our own raster backgrounds would be nicer. So how we imagine is something like one selects the background and obviously can zoom in and zoom out and select the well, which gives us then the very first table that pops up, shows us the well data. It's good for identifying the site where we are, and by selecting the tables which are behind the well, we can visualize, for example, the attribute table in table view together with the map, and there we can download the report. That's the very first, most simple. Hopefully we will have the resources to create more detailed query tools where one can, for example, lithium turns out to be a question nowadays, can select lithium values above a certain value and download the selected wells report. Although this one-by-one method would be easier, but some kind of reporting PDF that can be downloaded, put together, and we can kind of create a report from our investigation throughout the database. As you can see here, it's not all the entries are filled, and obviously I chose a well which I knew that quite nicely filled, but yeah, as it was mentioned before, there are like thousands of well data that does not contain later there is not related fluid data or rock or reservoir. So the final state, as long as we work on it, will still be of the database that there will be geographical areas where the data coverage is good, and there will be geographical areas where data coverage is poor. For example, Netherlands, Turkey, Hungary, Iceland, UK, quite well covered areas, and Italy, for example, we could not get. Obviously, it comes from the different availability of data, and yeah, that's the thing we have, and that's the thing we can cook with. Right now, still running work, these incoming data processing toolset, which cleans up. The IDs, coordinates, data formats are all right already. We have the references part, which we still have quite a big bite. We're already doing to set the server itself. It will get its own workstation for having the hardware backend, and we have our GIS license, so maybe our GIS server will run in the background, or we try to create it with the open source QGIS, for example, setups. And yeah, and the front end will be designed, and we figure out which query tools and symbology of automations can be created until the final publishing of the web-based European Fluid Atlas. And thank you for your time and attention. And yeah, thank you.
Thanks a lot, Károly, for the presentation of the Fluid Atlas and the preview. Are there more questions? Some question in the In the chat, there's one question: was the data for the atlas collected in accordance with national legislation and certain approvals? Would you like to answer this?
As far as I know.
I can answer that definitely yes, because we work only with publicly available data. So no need for special permission. These data are publicly accessible.
That's it. Thanks. I would also like to point out once more that the presentations and also the link to the recording of the webinar will be sent to the participants of the webinar in the coming days. So you will all receive the presentations. We have one comment on the data in Italy, that they are still dealing with the competent institutions trying to collect as much data as possible. But some are different, so often they are very close together and maybe they share the same reservoir, so they have pretty similar fluid chemistry, but hopefully more data from Italy will be provided before summer. I'm not sure whether we have other questions at the moment. I think not. At least I can't see things. There was a question before from whether the depth of the previous wells is identical to the new wells. I can maybe answer this. So there's no old and new wells. We have old and new data. Often they come from the same wells, but are taken at different time steps, or they are indeed from different wells and different locations. But it's just the difference between old and new is that some data has been existing before the project, and some data has been newly collected during the REFLECT project. So indeed, we performed the sampling during the REFLECT project and then analyzed the fluid for the chemical composition. There's one more question: when is the atlas supposed to be published? Károly, would you like to answer this?
The database behind will be published on this summer, and altogether a beta version will appear on this summer. And to the end of the project, end of this year, it will be ready.
Yeah, thanks. And I can also add, we still collect more data. So if one or the other geothermal operator is watching this webinar and would like to contribute more data to the database, or if you, from your previous research, have more data, we are happy if you contact us and we can provide the data template so that we even can include more data on the atlas, on this database. I think that's it for today. I would like to thank once more all our speakers for the presentations, for answering the questions. Again, I advise the participants that the webinar has been recorded and that will be made available on YouTube in the coming days. And yes, I think that's it. Thank you for your participation, and we hope to see you in our next webinar, which is already scheduled for May 11th on predictive modeling. So if you are interested in that, we hope to see you back. Thanks a lot, everyone. Have a good evening.